Chapter 25, we're going to be talking about intercepts and specifically x and y intercepts. Okay, and with respect to a line, which that's what this next series of chapters is about, along with the previous two. When graphing lines, a lot of times they intersect the x and y axis, and when they intersect the axis, we call that coordinate, the point on the x or y axis, intercept. Okay, so first let's take a look at the y axis. Okay, uh, in this figure below we have a coordinate system, uh, x and y axis, and we have some points plotted along the y axis. Okay, so let's take a look at the coordinates for each one. The coordinates for this point, well, to nail down the coordinates of a point, we reference ourselves to the origin, which is where the two axes intersect, and this is 0, 0. If we go to the right, then x increases by 1. If we go to the left, the x coordinate decreases by 1, so this is plus 1, and this is negative 1. Well, to get to these coordinates, we do not have to shift off of the y-axis. Okay, so x at the origin, the coordinate's 0, and so for all of these points, we're going to have an ordered pair. Okay, every point on the coordinate plane has two coordinates, and since all of these points lie on the y-axis, with respect to the origin, they sit directly above it or below it, and so the x coordinate for all of these points will be 0, and so all we have to do is count the y coordinate. Up from the x-axis we count 1, 2, 3, 4, 5. So this coordinate has this point has the coordinate 0, 5. This one we go up 1, 2 and a half, so 2.5. If we go up 1, and then if we go down 1, we get the last two sets of coordinates. So this is an important characteristic of the y-axis. Y-intercepts. Which are what we could call all of these points because they lie on the y-axis. Y-intercepts have the x-coordinate x equal 0. Any point on the y-axis, x-coordinate equals 0, and this is going to be important later on. We're going to actually use this to graph lines. Okay, so if you want to fill your workbook out, a y-intercept is a point 0, and y could be some real number, any number, but the x coordinate is definitely 0. Can't be any other number if this point lies on the y-axis. So you probably have a pretty good idea of where we're going to go with this next figure. Now we have a two-dimensional coordinate system, x-axis, y-axis, and now all of our points lie on the x-axis. This one actually lies on both of them, so this one's sort of special. It's the origin, of course, but we could call this an x-intercept and a y-intercept. It's both, okay, because it lies directly on the x and the y-axis. The other three, um, with respect to the origin, we do not have to shift up or down. We only go left or we go right to arrive at the points. So in this case, if we go to the left from the origin 1, 2, 3, left is negative. And so let's see, this point would have an x-coordinate of negative 3, and we're already there. We don't have to shift up or down off of the y-axis, and so 0 would be our y-coordinate. Okay, just like the origin up at the top. Now for this third point from the left, we go over 1, 2 from the origin, and so its x-coordinate is 2, and we're already there. We don't have to shift up or down. It lies directly on the x-axis, so with no up or down movement, y equals 0. And then the same for this point. We have y equals 0, and the x-coordinate from the origin, we would count 1, 2, 3, 4, 4.5. Alright, so what do you conclude about points that lie on the x-axis? X-intercepts have y equals 0. So at the bottom, the definition for an x-intercept is it's a point where x can be any real number, but the y-coordinate is definitely 0. There's only one possible number for the y-coordinate. This is true for all x-intercepts. So this page is going to give us a very simple way to graph lines. Okay, with a straight line, one thing you should realize right off the bat is that in order to graph a line, we only need 2 points. Okay, and most lines that we'll graph do have an x and y intercept. So what we're going to do is we're going to figure out what those coordinates are. So the key to finding the x-intercept is using the fact that any point that lies on the x-axis, y has the value of 0. And then any point that lies on the y-axis, down here at the about mid-page, any point that lies on the y-axis, x equals 0. So if you want to find the x-intercept, then you set y equals 0. X-intercept, the other variable's the y, set it equal to 0. If you want to find the y-intercept, then you set the other variable x equal to 0. Okay, and so that's what's been done here in this first question. We have this line 2x plus 3y equals negative 15. We know it's a line because the exponents of our variables are 1 for the x and the y. We plug in 0 for y. We're looking for the x-intercept, and now we only have one variable left in the equation, the x, and so to finish this, we divide both sides by 2, and we get a negative 7.5 for the x-intercept. Okay, using a 0 for the y, this gives us a point on the line. We use 0 for y, and we got negative 7.5. So here's a point, and it's a specific one. It is the x-intercept. Okay, same equation. So this represents the same line if we were to graph it on the coordinate 2D coordinate system. We're now looking for the y-intercept. So we take our x variable and we replace it with 0. And now we want to figure out what y coordinate corresponds to this x coordinate 0. So 0 knocks out the 2, and we're left with 3y equals negative 15. Only one variable, the y. So we divide both sides by 3 and we get a negative 5. And so this yields the point 0, negative 5, a different point than the previous one that we found. And this is a special point. We call it the y-intercept. Okay, so they didn't give us a graph, so I'll sketch my own. The x-intercept we found from the top was negative 7.5 and 0. So we have 2 points, and that's all we need to graph a line. On the x-axis, we go to the left 1, 2, 3, 4, 5, 6, 7, 8. So we want 7.5, so between negative 7 and negative 8. And then on the y-axis, we go down 5 for negative 5. 1, 2, 3, 4, 5. Right on top of negative 5. Here's our x-intercept. Here's our y-intercept. To finish the line, we just simply draw a straight line through the 2 points. And every other point, every other set of coordinates that would satisfy this equation lie in a straight path between these 2 points, or to the right and left, anywhere along this line. So we're given the graph of a line, and we're told we want to find the x and y intercept. There's really no math involved. We just simply have to know how to read coordinates, and we have to know what the x and y intercepts are. X-intercepts on the x-axis. It is located right there. Y-intercept is on the y-axis. It's where the line intersects the y-axis. So y-intercept. X and y-intercept are points on the 2D plane, and so we're going to have 2 coordinates for them. Okay, we don't want to just give the y coordinate. So y-intercept, we've got negative 6 here. So that's our y coordinate. And if a point lies along the y-axis, then x must be 0. For the x-intercept, y must be 0. And so we take the x coordinate and we read 2. So there they are, the coordinates for the x and y intercept. 2, 0, and 0, negative 6. Example 2, finding x and y intercepts of a line given the equation. So this is same procedure as what we were shown up above. If we want to find the x-intercept, then we set y equal to 0. So we take our equation and we replace the y with the 0. That'll knock out the 2, and there's nothing left to do but to bring it down to the next line, and there it is, x equals 6. If we want to put that in coordinate form, then we would write 6, 0 with parentheses. For the y-intercept, set x equal to 0. So we take our equation, we have a 0 plus 2y equals 6. What y coordinate corresponds to an x coordinate of 0? All we have to do is solve the equation. With x being 0, we're left with 2y equals 6. We divide by 2. We get y equals 3. So to put this in coordinate form, we would write 0 for x and 3 for y. Okay, another instance of finding the x and y intercept of an equation. So once again, x-intercept, y equals 0. Okay, the 0 of the x knocks out the 3, and we're left with 5x equals 6. Divide both sides by 5, and this gives us x equals 1.2 if you put it in decimal form. So a little past 1, a fifth. For the y-intercept, we set x equal to 0. This 0 knocks out the 5, and we're left with 3y equals 6. And now we divide by 3, and we get y equals 2. If you want to put in these intercepts in coordinate form, then we would write 1.2 comma 0 for the x-intercept, and 0 comma 2 with parentheses, of course, for the y-intercept. So in this situation, they're saying that we have this equation. They didn't give us the equation, but they told us that we know we have some information about this line, and that information is the x-intercept is -2 and the y-intercept is -4. So we plot those points. They're points on the x and y axis, and even if we didn't know the equation, if we were given this information, then we could still graph the line. All we have to do is connect these 2 points with a straight line, and we've graphed this particular line without the equation. Okay, and once again, it only takes 2 points to draw a line, but a lot of times what we do is we find a third point on the line just to double check ourselves. But if you do it right and you don't make any mistakes, you only need 2 points. And this last little bit is saying that we want arrows on the ends of the lines to indicate that we didn't draw the whole line, but it does continue to go up and to the left and down and to the right. It extends in those directions indefinitely. Example 4, graphing a line given the x and y intercepts. So we don't have an equation for this line, but we know the y-intercept is 3 and the x-intercept is -5. So on the y-axis, we start at the origin. On the y-axis, we go up 1, 2, 3. On the x-axis for the x-intercept, we start at the origin and we go left for negative numbers 1, 2, 3, 4, 5. We only need 2 points to graph a line, and now we connect these 2 points with a straight line, and then we put arrows on the ends, and that's all there is to it. For the y-intercept, if you needed it, then you could write 0, 3. And then for the x-intercept, you could write -5, 0. So here we have an equation. We're not told outright what the x and y intercepts are. So we have to find them ourselves. For the x-intercept, y equals 0. Any point on the x-axis, the y-coordinate is 0. So we take our equation, 4x plus 3y, and instead of writing y, we put a 0. The 0 knocks out the 3. We're left with 4x equals 12. We divide by 4, and so x equals 3. This is our x-intercept, so we can just go to the x-axis, count over 1, 2, 3 to the right for a positive 3, and place our point. Okay. Now for the y-intercept, x equals 0. So 4 times 0 plus 3y equals 12. This gives us 3y equals 12. 0 knocks out the 4. We divide both sides by 3. We get y equals 4. Just simply go to the y-axis, go up 1, 2, 3, 4, and place a point. You've got 2 points now, and all there's left to do is to draw a straight line through the 2 points as best you can, and then put arrows on the ends. Alright, so what if we have an equation that doesn't have an x and a y intercept? Well, it turns out that a horizontal line doesn't have an x-intercept. Okay, if it's not actually sitting on top of the x-axis. Okay, so if we look at this, they want us to pick out some points along the horizontal line. Okay, and we want to come up with the coordinates. So I'll just call this my first point, my second point, and my third point. And like the x-axis, x-axis is a horizontal line basically. This is a horizontal line, so there's going to be some similarity there. For point 1, what are the coordinates? Well, we go up 1, 2, so this is in line with y equals 2. And then our x coordinate from the origin is 1, 2, 3 to the left, so it's a negative 3. Okay, this is just simply point number 1. Okay, what about point number 2? What are the coordinates? Well, we go up 1, 2 for y, and then we go to the left negative 1, and so we have the coordinates negative 1, 2. Now, for the third point, we go up 1, 2 again, and then we go 1, 2, 3 to the right. So if you were to pick more points, you should notice that now for this horizontal line, every y coordinate for every point on the line is 2. Y equals 2 always. Okay, so we have a definition here. It says y equals a, where a could be any number, any real number, is the equation for a horizontal line. Okay, a special one. What is the name for the line y equals 0? It only has the y variable in it, and so it's a horizontal line as well. Well, y equals 0 is the x-axis. And so we could say that this line, y equals 0, the x-axis, has an infinite number of x-intercepts. So now we consider a vertical line. If we just pick a few points here, I'll label these 1, 2, and 3. Point 1, well, if we start at the origin and we count to the left 1, 2, 3, 4, that gives us a -4 for the x-intercept. So what's the y-intercept? Well, we have to go up 1, 2, 3 to get to the point. Point number 2, again, we have to go 1, 2, 3, 4 to the left of the origin. So that gives us a -4 again for the x coordinate. And now from the x-axis we go up 1, 2, 3. So we have a different y coordinate. My third point, I go 1, 2, 3, 4 to the left. And then I have to go down 1, so y would be a -1. And now we notice from looking at these coordinates that all of the y coordinates, all of the x coordinates are the same. This, yeah, I thought I noticed something was off about that. I should have put a 2 there. It's 2 up from the x-axis. So, yeah, all of the x coordinates are the same. They are -4, x equals -4 always. And so it turns out that this is the actual equation of this line. It doesn't have a y variable in it because y does not affect the x coordinate whatsoever. So when you see an equation of this type with only the x variable, then you should recognize it as a vertical line, straight up and down, a lot like the y-axis. So our definition, x equals b, where b could be any number, and it passes through the point b0. So for instance, x equals 2, well, it passes through the point 2, 0. Okay, so a vertical line has an x-intercept, and a horizontal line definitely has a y-intercept. What is another name? So a special instance of a vertical line, x equals 0. This line would run right over the top of the y-axis. Okay, writing equations of vertical and horizontal lines through a given point. Okay, write the equations for the horizontal and vertical lines passing through this particular point. Okay, so it's sort of backwards to remember. When you look at the 2D dimensional plane, coordinate plane, what's horizontal about it? Well, the first horizontal characteristic of the coordinate plane is the x-axis. But for a horizontal line, it is of the form y equals. For a vertical line, and you may not be this way, but when I think vertical, I think the y-axis. And so I have a tendency to want to say y equals, but for a vertical line, it's sort of backwards. We only have an x variable in the equation, x equals. So, you have to know this. So a vertical line, x equals, horizontal line, y equals. So given these coordinates, okay, where is this point? -7, 8. Well, the x coordinate comes first, -7, And negative means we go to the left 1, 2, 3, 4, 5, 6, 7. So we're temporarily right here. And now we want to use the y coordinate. Plus 8 means we go straight up 1, 2, 3, 4, 5, 6, 7, 8. So we're right here. Alright. So to draw the horizontal line that passes through this point, we just have to draw a flat line through this point that we just found. I'll put arrows on the ends. And then to just draw the vertical line, we start with this point and we just draw a line straight up and down that passes through this particular point. Okay, so if we draw the vertical line, where does it hit the x-axis? -7. So the equation for the vertical line is x equals -7. If we draw the horizontal line, where does it intersect the y-axis? 8. And so the equation is y equals 8. So in these types of problems, we sort of divide up the coordinates to the horizontal and vertical line. Vertical takes the x coordinate, horizontal takes the y coordinate. So example 7, we want to graph a vertical and horizontal line. Well, if you forget, you see this equation, x equals 3, and you're completely confused, and you don't know whether it's a flat one or a line that's straight up and down. You know it's one or the other. What you can do is just write out some ordered pairs. Okay. Well, where do your coordinates come from? They come from your equation. Okay, any coordinates that you write in these ordered pairs have to make sense with respect to your equation. And the only thing that your equation tells you is that x equals 3. There's no other option. Okay, there's no y variable in there. So take your ordered pairs and just run through them and write 3 in the place of x. And then it's up to you what you want the y coordinates to be. We could say 0, -1, 3, or -2. Plot these points. So we go over 1, 2, 3, and then we, for the first one, 3, 0, that would be this one. And then the next one, 3, -1, so we go over 1, 2, 3 on the x-axis, and for the y coordinate we go down 1, so we're right there. And so these points are falling on top of each other. 3, 3, we start at the origin and we go over 1, 2, 3 for the x coordinate, and then up 3 for the y coordinate. And at this point you should see that they're falling in a straight line that is vertical. So draw your line through your points. You only really need 2 points. Draw your line through them and put arrows on the end. Likewise, you have the equation y equals -2, and let's suppose you can't remember whether it's vertical or horizontal. The ordered pairs, the coordinates come from the equation, and the only thing it tells you is that y is -2. So you have to fill in the y coordinates of your ordered pairs with -2, and then your x can be anything. We'll say 0, 1, 2. Plot these points, and if you plot them correctly, so you know that this strategy depends on your ability to plot points. So we plot this first one 0, we don't shift left or right. The x coordinate tells us with respect to the origin whether to go left or right. 0 just means we stay put. And when we read the y coordinate, it tells us whether we go up or down and by how much. With a y coordinate of -2, we go down 1, 2, and we plot our point. So that takes care of this first one. What about 1, -2? Well, now we shift to the right 1, and we still go down -2, so our point falls right there. And we only need 2 points. These are side by side. If we draw a straight line through the 2 points, we get a horizontal line. If you drew the third one, we would get a point 1, 2 to the right of the origin and 2 down from the x-axis. And that completes chapter 25. Thanks for watching.